Hi everyone, I want to elaborate on the Khan Academy's video about convection currents driving plate tectonics. So I did my very best to draw the layers of Earth here. We have the crust in the top. It's actually much thinner than I represented it here. Then the mantle, which is actually the biggest volume inside of Earth. The outer core and the inner core. And now there's some research out there that shows there might be an inner core. So this is based on the current understanding of what drives plate tectonics. As you saw in the Khan Academy video, convection currents drive the movement of the mantle. Basically, the core heats up the bottom of the mantle through radioactive decay and causes the mantle to heat up and rise. But as it touches the cooler crust, it becomes colder, denser, and sinks to the bottom. So you get convection currents rotating the mantle. So what happens to the crust while the mantle is going through these convection currents? Let's focus on the crust for a second. So, first, you guys need to realize that there are two types of crust. There is continental crust, and then there is oceanic crust. But what's the difference between the two? Continental crust is made up of granite. Granite rock is less dense than the oceanic basalt. Both are igneous rocks, but the granite is less dense than the basalt. What that means is if you have collision between the two crusts, meaning that if they crash against each other, because the convection currents are pushing the plates towards each other. Let's say there's a plate tectonic boundary between the two, they're not connected. If the mantle is circulating this way and the oceanic crust is heading towards the continental crust, because the basalt is denser than the granite, it will sink below the granite. So the granite continental crust gets pushed up while the oceanic basalt gets pushed down and gets recycled into the mantle. So, this is why you can't take it for granted that we're made up of granite, excuse the pun, because if it was the other way around and the continental crust was denser, we would be the ones getting recycled into the mantle. So, the fact that the oceanic crust is made up of basalt makes it sink below the continental crust and saves us from going into the mantle. That would be extremely catastrophic. This collision between oceanic and continental plate boundaries happens more often in the Pacific Ocean. So that is why a lot of the earthquakes, volcanoes, and trenches are located in the Pacific Ocean. As you can see here, where the basalt oceanic crust is sinking below the continental crust, you kind of get a dip here, a little hole that forms as this plate is going underneath the other plate. That is what we call a trench. The deepest place on Earth is the Marianas Trench, which is located in the Pacific Ocean. There are 3 different types of plate tectonic boundaries. The one I demonstrated before with the granite colliding against the basalt, meaning the continental crust colliding against the oceanic crust, is known as a converging plate boundary because they're converging and crashing against each other. In the Atlantic Ocean, our continental crust and oceanic crust are actually firmly attached in a passive margin, and we are actually diverging in the middle of the Atlantic Ocean, getting further and further away from Europe. And on the other side, our west coast of the United States is converging to the Pacific and getting closer to Russia. So someday we will see Russia from our house. Here is a third type of plate tectonic boundary called a transformed plate boundary, where their plates are horizontally scraping past each other. That is actually what we see in the San Francisco area, where the San Andreas Fault is in California. That area west of the fault used to be part of Mexico several 100,000 years ago, and will someday actually belong to the Pacific Ocean in a couple 100,000 years, but not in the immediate future. The fact that basalt, meaning the oceanic crust, is denser than the continental crust means that it sits lower into the asthenosphere than the continental crust. That's why we even have an ocean basin in the first place. It's so much denser that it sinks. If the continental crust and the oceanic crust were made up of the same material, the entire Earth would be covered by about a kilometer of water, and we would have to grow gills. The crust and the uppermost mantle is actually known as the lithosphere. It's rigid rock that sits above kind of a Play-Doh-like plastic rock called the asthenosphere. I always use the Play-Doh analogy because it's a plastic toy that is solid, not a liquid, and moves flexibly. So when the core heats up the bottom of the mantle, it causes the mantle to fluidly move up, but it's still a solid. So the asthenosphere is a solid, is just more plastic and fluid, while the lithosphere, which is the uppermost part of the mantle, and the crust is rigid rock. So this is an image of what scientists understand is happening to our Earth. So every year we get about a centimeter away to 10 centimeters away from Europe, because in the middle of the Atlantic we have a spreading zone where we have diverging plate boundaries and the plates are moving away from each other. So we're getting further and further away from Europe, like I said. But in the Pacific coast, our oceanic crust is subducting at a converging plate boundary, and we're losing land there. It's getting recycled back into the mantle. When a subduction occurs like this between oceanic to oceanic plates, you still get trenches, but you also get volcanic islands forming. Things like the Philippines and the Alaskan Aleutian Islands were formed because plates of oceanic crust were colliding against each other. Hawaii, on the other hand, is just a weird abnormality we call a hotspot, where a random breach of mantle plumes come out and form volcanic islands nowhere near plate tectonic boundaries. Now, if the oceanic crust were to subduct with continental crust, at this type of converging plate boundary, you get mountains on the continental crust, you get volcanoes, and you get the world's deepest trenches like the Mariana Trench or the Puerto Rico Trench near the Caribbean islands. If you recall, a lot of our plate boundaries that look like this between oceanic to continental convergence are located in the Pacific coast, the west coast of the United States. That's where we have the Rockies, and we have volcanoes like Mount Rainier and Mount St. Helens. Now, here's food for thought. If we are nowhere near a plate tectonic boundary in our east coast, that's why we don't get as many earthquakes, why is it that we have the Appalachian Mountains? I'll give you a big hint. We used to be close to Europe, and we have been moving away from Europe. So, when the United States used to crash against Europe, the Appalachian Mountains were formed. The Rockies are much bigger than the Appalachians because they're newer, while the Appalachians are old and have been eroded and broken down ever since.